This is Between the Brackets, a Mediawiki podcast, episode 55, March 3rd, 2020. Welcome to Between the Brackets. I'm Yaron Koren. And my guest for this episode is Erik Bernhardson, who is the tech lead for the Search Platform team at the Wikimedia Foundation, which is the group that handles search, as you might imagine. There hasn't been a discussion yet about search on this podcast, so I'm excited to talk to him about it. Erik, welcome to the podcast.
Hi, thanks for having me.
Where do you live?
I am kind of in the exurbs of San Francisco. About a 2-ish hour commute outside of San Francisco.
Oh, okay. So how often do you visit the Wikimedia Foundation office, if ever?
Not often. I used to live in Oakland, which is just across the bay. I used to go into the office all the time. But since then I had a kid, growing a family, we moved a little farther away, and I don't work with anybody in the office anymore. So everybody I work with is like, they're in Switzerland, or they're in France, or they're in DC, or they're somewhere else. There's not a whole lot for me at the office. So I think you've talked to a lot of people with a similar thing. Like, even if they're near the office, there's the people they work with aren't near the office. So there's not a whole lot of going on there.
Yeah. So far, this is the 50-something episode, and there's only been one person who works at the office full time. There's another guy who works there. The trick is you got to talk to accounting or legal. I think legal is mostly in San Francisco.
I don't know if they want to talk publicly, but
well, I don't know how interesting that would be to the Mediawiki audience.
I think legal does a lot of very interesting things, but
okay.
So, I mean, they would be involved in suing the NSA over the privacy things. They're involved in getting us back in Turkey. I mean, not them personally. They're kind of orchestrating these kinds of things. They have individual law firms they work with that do the actual work in the country. Not really Mediawiki related.
Sure. But there is an opportunity for a podcast that explores more of the Wikimedia Foundation side of things and Wikipedia side of things. There's some Wikipedia podcasts, but there's always room for more.
Okay.
If anyone there is listening, or if you want to do it, talk to some accountants and lawyers or whatever else. Yeah, the turkey thing is interesting, but we're not going to talk about it.
I know nothing about it either.
Oh, okay. Well, so how did you end up working for the Wikimedia Foundation?
So you might be aware the foundation and the wikis have been on Freenode, which is an IRC network, for a long, long time. I've also been on Freenode since 2000 something, probably. Essentially, I participated in programming-related chat rooms, and I met people from the foundation, Patrick Riley, actually. And I was answering questions he had about things that they wanted to do, and eventually he asked me if I wanted to apply for a job. And I suppose random fun thing, Patrick Riley got fired before I started.
Okay. That's...
I never actually met him besides online.
I see, okay. Did that make you doubt, question your decision? Okay.
No, not at all.
Yeah, what year was that?
Oh gosh, that'd be 6 years ago. So what does that make it, like 2013, 2014?
Yeah. So what were you doing before you started working there?
Before then, I worked for essentially a generic PHP consultancy. Like, we would take on projects. So like a project I worked on just before this was on it's a thing called a penny auction. These are weird sites where essentially I don't need to explain the whole concept, but essentially they were penny auction sites, and I rebuilt the way the bidding process worked so it was more scalable, so that it didn't fall over when people were doing too many bidding, were bidding too often. So essentially other back-end software development, PHP, server-based stuff.
Yeah. Cool. Were you hired to work on search, or did that part come about later?
No, that came later. I was originally hired to join the editor engagements team. Editor engagements was just finishing up Echo. And so I guess the very first thing I did at the foundation, I spent like a month writing tests for Echo to make sure that it would keep working. And then that team moved on to do the Flow project. The Flow project ran for a little while, and I asked to, when I heard we were having a reorganization at the foundation, I asked if I could move on to the search team. And that's how I ended up on search. And I've been here 4 years maybe on search, something like that.
Yeah, okay. Oh, so you had no search experience before you started doing it?
No, none at all. I wanted to work on something different, and there was this reorg, so I had there was the opportunity to just ask and get put on a different team. So that's what I did.
Yeah,
Search sounded interesting, and it was a team so I suppose this gets into another interesting thing. I don't know if you want to talk too much about it, but that's like the Lila Knowledge Engine era. That's how the search team got started. So there was a plan at the time for it to be very big. So there were lots of spaces available. So I just asked for one of them and they gave one to me. Now, of course, Knowledge Engine never happened. Knowledge Engine never really made it out of the C-suite. Like that was a thing that Damon and Lila and other people were talking about and planning that never went anywhere.
Yeah, maybe the people listening who aren't aware of all the history of Wikimedia Foundation drama. Should know about it. If I can explain it briefly, that it was I guess maybe just a PowerPoint idea or something. I don't know if anybody actually wrote any code for it at any point, but there was there's at some point at least the possibility, depending on whom you ask, that Wikipedia was going to try to have its own search engine to compete with Google or something.
That was Damon's plan essentially. Damon was CTO of the foundation at the time.
Yeah, Damon Sikor or something.
Yeah, that's the one.
Yeah. Were you involved with all of that in any way?
So I mean, the discovery discovery department was created at the time, and we hired on a few people. But while they were talking about Knowledge Engine and competing with Google, the things we were building at the time, so we built the completion suggester, which is on all of the Wikipedias, when you type, or not just Wikipedias, all the wikis, when you type in the upper right-hand corner, there's a box there that you can search in. That used to be a very strict prefix search. And so at the time, we worked on making that fuzzy so it can account for typos and things. So now you can type a couple characters wrong and you'll still get auto-completed to the right thing. So those are the kinds of things we were working on at the time. We were just looking at wiki search, looking at things that weren't good and seeing what we could do to improve them. We never got to anything having to do with like crawling the web or indexing other people's content or even trying to figure out what that means.
Yeah. Okay. You mentioned the flow extension. There was Echo and then there was Flow. Speaking, I guess, of drama, sort of. Not nearly as dramatic, but
there was drama around that too.
Yeah. Okay. For people who don't know, that's Flow, which is now called StructuredDiscussions. I don't know who came up with that name change, but it's basically an extension that adds a whole interface to talk pages, so you can have threaded discussions without having to know the syntax of colons and tildes and all that.
Yeah.
So what was your involvement with that extension?
So I was tech lead for that project as well. That project, it never got anywhere near where the original plans were. So the original plans for Flow was not to be a structured discussion system. It was supposed to be a workflow system that would allow people to kind of describe their workflows to the system in a way like maybe your I don't know, various workflows on wikis like voting, but I know voting is not like the term that they like to use.
Well, yeah, I mean, if you want to delete a page on Wikipedia, there's like 5 steps you have to take, and lots of copying and pasting and everything. Yeah.
And so the original idea was that this was supposed to be a system for allowing editors to kind of define and use workflows, but it got mired in the discussion aspect of it, the structured discussions, and never really went beyond. And the structured discussions really wasn't having much uptake on the communities. They weren't, some of them were interested in using it, but most of them, it didn't cover enough workflows for it to be used. There were lots of things that people were doing that you couldn't do in Flow because it only handled discussions. So essentially, my involvement there was, I was tech lead. I worked on it for a few years with a couple other people, and eventually it asked to move on.
Yeah. Well, let me put you on the spot a little bit, but what do you personally think about the Flow/structured discussions interface as a talk page tool?
I still use it. So I still use it, but I don't use it as a talk page like regular people do. So, for example, on Mediawiki.org, there's a page called Help CirrusSearch. And there's a talk page associated with Help CirrusSearch. That's a structured, that's a flow page. Whenever anybody creates a topic there, any wiki I visit in the WMF sites, I get a notification that says, hey, somebody created a topic over here. So when I'm debugging some random thing, I log into the Japanese Wikipedia, I get a little notice, and then I know that I need to go stop over at Mediawiki.org, read the talk page, give somebody an answer to a question. So that kind of functionality is very important to me, very useful. But I don't use talk pages like editors do for actually discussing editing the content of a page. So my use case is very different, and I understand why we have different needs there.
Okay, that's interesting. Yeah, it's you want to be notified if people have questions for you and that kind of thing, as opposed to
discussing how to change the content of a page, proposing differences, and then collaboratively editing those changes until you decide.
Yeah,
on the
strangely,
solution.
I've never seen that on MediaWiki.org. Now that I think about it, people just make whatever changes they want.
That is one of the big things that people were complaining about that they couldn't do with Flow is they couldn't collaboratively edit something to then put into the page later.
Yeah. Right. It certainly is trickier. And actually, I should take that back. There have been a few cases where people looked at some documentation for my extension and said, what about changing this paragraph or something? Usually people just do whatever they want. But
yeah.
So, yeah. Okay. Anyway, let's talk about search. I know search on Wikipedia and Wikimedia sites in general is a huge deal. But how huge a deal is it? I mean, how many searches are there altogether per second or per minute or whatever the standard metric is?
So, I mean, just ballpark, we're serving around 1,000 autocomplete searches per second. We're serving around 400 to 500 full text searches per second. And we're serving, at the server layer, we're serving about 200 related articles searches. Those are the articles you see at the bottom of a mobile page that suggest other.
Oh, yeah, on the mobile interface, yeah.
But that 200 per second is actually heavily cached. It's about 5 or 8 million per hour if you go to the edge. I don't know what that works out to per second, but
wow.
But so amongst everything, there's probably over 2,000, 3,000 requests per second that are resolved by the search infrastructure.
Wow. How much of that is just the English language Wikipedia, do you know?
So English language the Wikipedia accounts for less than 50% of traffic. It's still up there, like it's 45 or 42 or something like that. I don't know exactly, but so it is less than 50%. Which kind of leads us to our focus. We try to focus not only on English Wikipedia because it's not even half of our users.
Right.
And so we need to make sure that we're focusing on everybody and not just this one site that happens to be really big.
Yeah. So the autocompletion thing is interesting. Is that a completely separate process from handling regular searches, or?
Yeah, it uses
at least some
a
code
completely
in common.
separate search index, like a different data structure that is used to handle it. It's like full text search has some giant files on disk that add up to terabytes, whereas autocomplete has to fit inside of an in-memory tree structure. Essentially, all of your autocomplete stuff is held in memory in our search cluster continuously. It's a separate data structure, separate process. But that allows it to answer. So full text search probably answers average 80, 100 milliseconds. Completion search about 5 milliseconds in terms of back-end query time. There's still like PHP processing and other things that have to happen. But
wow. Okay. Wait. So
essentially, there's an order of magnitude difference between the amount of work that we do on an autocomplete, and it's by using these special data structures, which we don't implement. They're provided by our search engine. Yeah.
So you're saying the thing that the handles autocompletion is entirely in memory on one server or something, or
it's split across.
How does that even work?
So there's 35 servers in each data center that handle search.
Wow.
It's about 3.5 terabytes of memory for each data center, something like that.
Oh man!
And then that's what it just fits in there somewhere. It's just split between the different servers. There's probably like 8 servers that have copies of English Wikipedia autocomplete, and there's probably like 4 that have copies of French and whatnot.
Yeah. Wow, that's amazing. Well, yeah, so of course I want to talk about the Wikipedia/Wikimedia setup, but this is a Mediawiki podcast. And so before we get to the interesting stuff, I think a lot of people listening to this run their own wikis, and most of them are just using the default Mediawiki search. So can you explain the mechanics of the basic Mediawiki search?
So the basic Mediawiki search, essentially SQL engines, whether it's MySQL or whatever, they usually have something called a full text search built into them. And this is what Mediawiki uses. Full text search in these has gotten better over the years. It's like what you can get out of Postgres today is 10 times better than what you could get like 8 years ago. And like you can do a little bit of analysis chain stuff. Analysis chain stuff is where you process the text into a simpler form. So like in English, if you search for dogs, I want to find the word dog, so we just throw that S away. But you have to, so that kind of analysis is something that you can now do inside of these SQL search engines. Usually not as fancy as we can do inside a real search engine, but so essentially you have a
and know some basic rules of grammar.
Yeah, and it might only know it for English, and it might only be able to tokenize words that have spaces between them. So don't try and send it Chinese or something like that. But but the basic search engine. So essentially, it's MySQL or PostgreSQL or whatever. It's a full text index field, and essentially, it's able to chop your text up into words, basically, and search for them. Yeah.
So Mediawiki isn't really doing anything.
Nothing fancy at all.
Beyond that,
it's
takes
basically
the results
whatever the SQL engine is able to provide.
Yeah. Okay. So as far as the actual Wikimedia search setup, here's what I understand about it, and which is not much. So there's an open source application called ElasticSearch, and then there's a PHP library called Elastica that connects to it, and then there's a Mediawiki extension also called Elastica that uses Elastica the library, and then there's another Mediawiki extension called CirrusSearch that uses Elastica the extension, and then I think there's some custom code running on top of CirrusSearch that's just for Wikipedia and Wiktionary and those sites, though I could be wrong about that last part.
I don't know if there's some custom tracking stuff inside of Wikimedia Events extension. This is something that basically records click-throughs and helps us to tune the search engine in the background. But in terms of actual functionality, I don't think there's much for actual functionality.
Okay.
Like there's other extensions like Wikibase CirrusSearch, which is kind of like the thing that glues Wikidata and CirrusSearch together. But I mean, that's I don't know. That's a whole nother ball of worms.
Well, yeah. Okay. So all the logic for handling all the languages and so forth is contained in CirrusSearch.
Yeah, we try and keep almost everything contained into the CirrusSearch repository, just to have one place to look for things. But that's where we keep all of our different language handling stuff. That's where query parsing happens. Most of the stuff.
Okay. So here's my, I guess, the most technical question. There's actually one more layer, which is that Elasticsearch itself contains a library called Apache Lucene.
Yes.
And Lucene, for people who don't know, I believe was actually used directly on Wikimedia sites from, I think, 2008 to 2015. That's what I have.
Yeah, something like that. Somebody wrote a custom search engine a custom server around. Like Lucene essentially provides the search engine, the data structures, and the disk storage and whatnot. And then LSearchD, which is the project you were talking about, basically put a server on top of that. Basically made it serve requests. And yes, it was replaced with CirrusSearch. The reason for that replacement essentially boils down to that our operations department kept having to keep LSearchD alive, and it was getting harder and harder over the years, and nobody knew how it worked. So eventually, they decided to replace it with something modern and supported.
Yeah. Well, so that gets into my basic question, which is, so there's 5 layers: Lucene, Elasticsearch, Elastica, the other Elastica, and CirrusSearch. Could you explain what each of those 5 layers do?
Sure. So at the very bottom, you have Lucene. As I mentioned, Lucene has the data structures. This is essentially like the actual like storage of all the words and the ways to look up the words and to look up the things. It's called an inverted index. It's the primary name of that kind of thing. ElasticSearch builds on top of Lucene. ElasticSearch provides a clustering solution. So essentially, Lucene is just a library. You can't, to query it, you need to write a bunch of code. So ElasticSearch is that bunch of code, and then ElasticSearch coordinates splitting your data amongst a bunch of different servers. So like, I don't know, English Wikipedia is probably got copies of its content on 30 of our 35 search servers in the Echiad cluster. Right. And that's all handled by ElasticSearch. We just tell it, split this data into eight pieces and then copy it to 3 different servers each, and then it handles figuring out how all that works. And it handles, one server goes away because its disk died and it just removes data around the cluster. ElasticSearch basically handles, the clustering solution. It handles all of that. You step up, you have the Elastica library and the Elastica extension. The Elastica library is just a standard client library. It essentially provides a nicer way to write Elasticsearch to talk to Elasticsearch from PHP. There are similar client libraries for most languages. The Elastica extension in Mediawiki is actually something that maybe should go away at some point. So when this was created, there was no good way to use external libraries in Mediawiki. This was before Composer. This is before, really, Mediawiki just wasn't using external libraries at the time. Like maybe there were 2 or 3. So the Elastica extension was a hack that was invented to basically pull this one library that we needed into the Mediawiki ecosystem. But today it could probably be replaced with Composer. There's like 2 or 3 class files in that extension.
Okay, yeah.
Yeah. So that extension mostly, it should go away at some point. It's a vestige of time gone by, essentially. But it's not annoying enough to, it's actually more work to get rid of it than it is to keep it. So that's why it hasn't gone away yet. Yeah. And then you have CirrusSearch on top of that. And CirrusSearch is where it's essentially the integration layer between Mediawiki and Elasticsearch. So this, it attaches to the various Mediawiki injection points, such as the full text search, the nearby search, or the near match search, and other things. And then it tries to do things with it. So it tries to parse your query and decide, like, do we need to do a really simple query parsing, or are you using a bunch of fancy things like in source, or essentially we have a bunch of keywords that you can use in search, and your query gets parsed different ways depending on if you're doing fancy editor things where editors want to search for pages that have specific templates or don't have templates or various magic things. CirrusSearch provides all that stuff. And then I suppose there is one more layer on top that you're not going to be using outside of the foundation, but about 1.5 years, 2 years ago, I wrote a thing called MjoLniR. MjoLniR is a machine learned ranking library. Essentially, this takes a bunch of click data from our various sites, runs it through a bunch of statistical algorithms, and spits out a machine learning model at the end. And then that machine learning model, we actually generate different ones for different sites, but there's about the top 17 sites that WMF runs. Their final ranking is all chosen by a machine model, as opposed to us hand tuning the ranking algorithm.
Yeah. And all right, I guess that's everything. that's all the layers.
That's hopefully the high level. I'm sure there's more stuff in there, of course, but
yeah. So the language support stuff is very interesting. Mm-hmm. How many languages do Lucene/Elasticsearch support on their own? I mean, first of all, does Elasticsearch actually handle any of? Should I just be asking about Lucene? Does Elasticsearch actually handle any of the search stuff?
So they do. So essentially, Lucene under the hood has analysis chain stuff. Analysis chain is just a generic word for everything that handles text processing. They have some stuff in Lucene. So like you're going to find like a Chinese tokenizer inside Lucene or something like that. Elasticsearch will tie those together though. They'll say like when I tell Elasticsearch I want to do a German analysis chain, it'll pick, German stop words, and it'll pick German tokenization, and it'll pick like the appropriate way to handle different characters in German, like the Esset and other things have to be handled specially. But although Elasticsearch provides those, we have a linguist on our team, Trey Jones. And one of the things he's done is go through and actually look at what comes out of the analysis chain, what words or what tokens are coming out of it. And so he's done a bunch of work improving the analysis chains beyond what Elasticsearch or Lucene provide directly. And often this comes about because we have weird use cases. Like if you're parsing a German page and there's a poem in Vietnamese in the middle, because this is a page about a Vietnamese poet, like that should also be handled correctly. And most things don't handle this mixed use case very well. So it's something that we've had to, or the way that Trey has had to spend a good deal of time figuring out. And sometimes you just don't handle it well.
Yeah. So the whole, I guess tokenizing is like a big part of improving search from what I understand.
Getting the right tokens is incredibly important. Like you can only find, like search essentially boils down to split your string into a bunch of individual strings of characters and then find pages that have all of them. And so a lot of the magic happens in that tokenization and analysis phase to make the tokens be the tokens you want to find.
Yeah, so the idea with tokenizing is you take sentences or whatever it is and you figure out what the important bits are of each sentence.
You try and find the separate words and maybe you try and simplify them down. I mean, so this is more than just tokenization. This is the full analysis chain. But essentially, after you split it into words, using spaces or using punctuation is the easy way in English at least. But after that, you have to process the words into some normalized form. Or actually, you tend to keep both. You keep the full form and you keep a simplified form. But that simplified form is what allows you to search for dogs and find dog. Or there's much more complicated versions, but that's the easy example.
Yeah. Have you had to learn a lot about the mechanics of different languages? I mean, I know you're not a linguist, but still.
So I punt most of the linguist questions to Trey. Like when we get a bug report and it's like the MjoLniR wiki is doing this weird thing when I search for this, like I learn about it when Trey tells us about the solution and what was wrong. But still, I send most of them to him because he knows those things well, and I have to start out by like, I don't know. I'm not super familiar with what to even do in those cases. Like, you gotta start. Trey has a mountain of things he's worked up over the time to figure out what to go.
Well, still, I mean, you're dealing with, I think there's about 300 language Wikipedias.
Yep. So to be fair, we probably only really think about maybe the top 50 languages. Like, we do think about them a little bit, but I mean, a generic rule of thumb is kind of like if you have a wiki with 10,000 articles, your search doesn't have to be super amazing. Like, it should be acceptable, but it doesn't have to be super amazing. If you have 1 million articles or you have 5 million articles, then search becomes a lot more important. Like if you have 10,000 articles, chances are you choose a word, it's in 20 articles. You just look at the list of 20 articles and figure out which one is the one.
You'll find the thing you're looking for if it exists at all.
Yeah.
Yeah. So what happens if, someone from the lower Sorbian Wikipedia writes and complains that they're getting bad results for some search terms?
So Trey or I or David we'll try and look at it a little bit to see if there's an obvious solution. Sometimes things have an obvious, simple solution. Like sometimes it's just something like they use particular accented characters, and I forget which language, but there was one language where like there's two versions of the I, or what I think of as an I. To them, it's not an I. But we were normalizing them both into the same Latin I character. And they're like, no, those are actually two separate letters. They're not the same letter in any way. It'd be like changing an R into a P. You're like, it's just got an extra line there. It's
Turkish, maybe?
And so
speaking of Turkey.
It might have been Turkish, yeah. But anyway, so I mean, things like that, it's relatively easy for us to say, oh yeah. And then we can go in and we can basically just say, like, protect this character. Like, don't change this character. Just keep it as is. So those kinds of things we do. But if something's a bigger problem, I don't know. So, I mean, Trey has also been working on something recently. Now I forget what language it is. But essentially, there is a language where you can type characters in different orders, and you get the same word.
Oh, man.
And so there is a canonical definition of which order they should be in. But people will write the article in one, and then they will search for the other one, and they won't find it because the letters are in a different order. And so Trey has figured out how to reorder things. And then we have a new member on our team, Miriam Stiles, who is working up an ElasticSearch plugin that will essentially do this. And then anybody who uses ElasticSearch can get this language in there. I think it's, gosh, I forget which one. It's an East Asian language. I forget which one though.
Yeah. Okay. Yeah. Do you guys ever send code back to ElasticSearch or Lucene to
So sometimes
to try to improve their handling?
A lot of that language analysis chain stuff hasn't moved back up. I suppose the biggest contribution we have. So I mentioned that MjoLniR project before that does machine learned ranking. To do the ranking with machine learning inside Elasticsearch, we needed to develop a plugin. So in collaboration with another organization called Open Source Connections, we built out a plugin for Elasticsearch that does machine learned ranking. And now this is used at a variety of places like Yelp and LexisNexis, I think, and a number of other places. And so this is an open source plugin that anybody can download. It's used by lots of different places.
Oh, cool.
But it's a collaboration. It's not just us. It's also the Open Source Connections people writing that.
Yeah, okay. What's it called again? Machine ranked.
So the project is called MjoLniR. MjoLniR is the hammer of Thor.
Oh, I see. Okay,
that name because it had. Well, you have machine learned ranking, which is MLR, and MjoLniR happened to have MLR in the right order, and so we just went with it. In retrospect, it's not the easiest name to say, and I know one person that calls it Meow Meow because she can't say MjoLniR, and so she just calls it Meow Meow. It's like whatever.
That works too. Yeah. Yeah, okay. I'll have a link to that from assuming there's a page for it.
It's perhaps interesting. I don't know if anybody outside us can use it because it's heavily tied to the way our infrastructure works, the way our analytics infrastructure, the way that we're able to access resources.
Oh, okay. Wait. So what is the tool being used by Yelp and the others?
So that is the plugin. So essentially, MjoLniR is the code that generates the models. The plugin for Elasticsearch is the one that runs the models at query time. So essentially you have a background process that generates machine learning models, generates a bunch of statistics. And then at query time, every result, the top 40,000 results are all run through this model with your search query to determine the final ranking of your search query. So that's called the ElasticSearch Learning to Rank plugin.
Yeah, okay. All right, cool. Yeah, I'll
that has amazing documentation written by the Open Source Connections people. I'm sure that wouldn't be nearly as successful without their documentation.
Yeah. Cool. Yeah, I'm seeing the page. I see the page here for it now on Read the Docs. Cool.
Yeah.
So yeah, I mean, well, okay, you don't really handle language questions. It's crazy to me how I mean, obviously I'm used to a certain set of languages that have a fairly standard approach. They all use the same punctuation and so forth. But then there's languages where there's no spaces between words, just crazy. Well, to me it seems crazy aspects of these different languages. I guess Latin too didn't use spaces, but or when they were writing it on tablets or something. But how do you even handle a language with no spaces? I'm as a how does software handle that?
So essentially, other really smart people wrote it. So in the case of Chinese is kind of maybe it's the largest example of a spaceless language, perhaps. In Chinese, there is a special thing inside of Lucene that uses a technique called hidden Markov models. I suppose it doesn't matter what those are. At the end of the day, they have a bunch of statistics about if I have these two characters, then most likely, then 40% of the time there's a break after it. And if I have these 5 characters, then 70% of the time there's a break after it. And it's got a giant dictionary essentially with a bunch of probabilities. And based on those probabilities, it tries to figure out where the actual breaks are in a Chinese sentence.
Yeah. Okay.
bit crazy, but it apparently works reasonably well. But we've tried similar things. So Japanese is another big language that's spaceless. And today we do not have any good tokenization for Japanese. The way Japanese search works is we chop it up into overlapping 2-character pieces. So like just imagine a sliding window of 2 characters going over the entire text. That's what we index, and that's what we search for in Japanese.
Wow. Okay.
That's actually what you get in most spaceless languages, unless we have a specific analysis chain that's able to handle it. We did evaluate a special analysis chain for Japanese about 2, maybe 3 years ago. But whenever we do these changes, we try and review it with actual speakers and actual people that use the wikis in that language. And the Japanese one, the people that we talked to and interacted with, they weren't impressed with the change in results that happened from this new chain. So Japanese doesn't get anything fancy. They're still on the old bigram model. But hopefully we will revisit that.
Yeah, that's interesting. I mean, you'd think there'd be a ton of software that can handle Japanese.
So there is, but it doesn't handle our specific use cases. Things like having a bunch of English text in the middle of a Japanese page, or having a bunch of Russian text in the middle of a Japanese page, and also, I don't know enough about Japanese, but I remember something about them telling us that there's various levels of tokenization that you can do in Japanese. Like you could do very strict, very traditional, or you could do something that's more colloquial, something that's more normal every day. And the one that we had was being very strict, and they didn't like the way that it was coming out of that. But this is a thing that we will hopefully revisit, because as I mentioned, Japanese is definitely the biggest spaceless language that doesn't have any special support. The other ones like Thai and Chinese are getting special stuff that makes them acceptable.
Yeah, okay. So back to ElasticSearch. I was reading about ElasticSearch. I had no idea it was as huge as it is. So here's my understanding. It started out in 2010. There was just a guy, an Israeli guy, apparently living in Europe who started the project. And then in 2012, he started the company called Elastic around the software. Mm-hmm. I was very surprised to read that they actually went public in 2018, and they're listed on the New York Stock Exchange. They have a valuation of about $6 billion.
So surprising thing, they're called ElasticSearch, but what they search is not what people typically think of as search. So kind of the bread and butter, the money making of Elastica, the company, or Elastic, the company, is operational logs. So when you hit a Mediawiki server, it might generate 10 log messages that have to go somewhere, so that somebody can debug a problem later. But there's not just 10. There's, hundreds of servers all doing this. You have 10,000 messages a second coming in. Yeah. People need a way to search through those to find a specific thing related to a problem. So what Elastic, the company, primarily sells is a solution for taking all these log messages from all the different things that you run, putting them into a single place, and then being able to search over those things. And I think the reason you hit on it with the $6 billion valuation, the problem is almost every technology company has a log problem. They have logs, they need to search through them. Not everybody has a search problem, or at least not a complicated search problem.
Right.
E-commerce has a complicated search problem, or at least a search problem that deserves spending some effort on because it will make them more money. But a lot of organizations, search just isn't an important thing to them. And so the way Elastic, the thing that they're doing, as I said, it's log processing, because that's a problem everyone has. Every technology company could potentially use ElasticSearch or the Elastic Stack as their solution. And so a minor aside, there's actually a competing Lucene search engine. So there's one called Solar, which is actually built. It's in the same repository. Like Lucene is structured as a project. Like Solar lives in the same thing as Lucene.
Oh, they're both Apache.
Yeah, they're both Apache projects. But then ElasticSearch is on the side, and we use ElasticSearch because when they first tried to replace LSearchD, the old search engine, they tried to use Solar. Solar, at the time, I don't know about today, but at the time it was very difficult to deal with 900 wikis and having all these different sites. It really wanted you to manually manage these kinds of things. Whereas with Elasticsearch, they kind of take that Elastic thing to heart. Like you can just keep stuffing data in there and creating more indexes.
Okay.
I mean, it'll have problems eventually, but you deal with them. It's much more flexible in terms of operational things. But anyway, so within the search industry, though, most organizations are probably using Solr. Most organizations where search relevance, where the quality of search results is important, most of them are probably using Solr, but most of them don't have the problem that the foundation does, where we have 1,000 separate sites. Most of them, they're like an e-commerce company and they have 2 sites. They just need to make sure that, that the right shoes show up at the top of your search.
Sure. Yeah. Solr, that's SOLR.
Yes, SOLR.
So really that was considered for use on Wikimedia sites?
It was initially, that's what they initially, I think, tried to deploy prior to switching to ElasticSearch. So this would have been just before me. This would have been, so when I joined the team, they were just finishing up the move from LSearchD to CirrusSearch. And so that was just wrapping up. So I just have a little bit of the history, but I wasn't involved in actually doing it, so I don't know the exact details. But essentially, they tried to deploy Solr operationally. It was just too much work, and they switched to Elasticsearch, which, seems to have worked out. I do see, like when I go to conferences or when I talk to people, some of them are surprised we're on Elasticsearch instead of Solr because it's harder to get good search relevance out of Elasticsearch. But I suppose as an example, like that Learning to Rank plugin, there was actually already a Learning to Rank plugin written for Solr by a team at Bloomberg. And we essentially just took their idea and re-implemented that idea in Elasticsearch.
Yeah, okay. Yeah, Elasticsearch really is geared toward logs specifically.
Yeah. I should say, like, it's a good enough search engine. Like, it totally does all the things. Like, Lucene is still providing all the same basic support. It's just when you look at what the focus of the company and the organization is, it's definitely about logs and log handling and, ingesting 10,000, 100,000 messages a second, that kind of thing.
Yeah, with that much data, that starts to sound like a big data thing where people would consider using, I don't know, Hadoop or whatever the current...
So the difference there is that so you can do anything in Hadoop. We use Hadoop for various things. But when you want real-time answers, usually Hadoop is not any good for real-time. Like when I issue a query to look through our search logs on Hadoop, it might take a minute or 2 minutes to give me a result for what happened that day. Whereas when you go to the Elasticsearch interface, even if you're searching through millions of messages, you see it on Wiki. Like you can search for "the" on English Wikipedia, and it will return 6 million results in about a second.
Okay. Not generally useful results, but still.
Yeah, if you're lucky, if you search for the, hopefully we find the band the.
Yeah, right. I was actually thinking about the.
There are. I wonder. I'm sure they do that intentionally, just to.
They knew they knew ahead of time that.
Oh, of course. the like.
Actually, I know people who know someone from the. They were
okay.
They're. Yeah. This guy was saying, he had the connection.
Or I suppose,
anyway,
I suppose the canonical search example of that one is to be or not to be.
It's a
all of those words are words that you would traditionally just throw out.
Sure, right.
But if you throw them all out, you can't find the quote.
Yeah. So how do you handle that?
We keep both copies. We have the one with all of everything, and then we have the one with stop words and other. Essentially, we have what we call it a plain field, and the plain tries to be as accurate to the source as possible. And then we have another version which is like heavily normalized, where we throw away stop words, we get rid of accents, we remove plurals, we try and if it's German, we try and split it into the separate words instead of having just the long word that's 4 different words combined.
Yeah. Oh, right. I think testing is one of your big focuses, if I'm not mistaken.
Yeah, I'm a big fan of testing. I'm a big fan of being comfortable enough to deploy something and not be worried that it's going to break. And testing is the way to get there.
Yes. Okay. Yeah. I didn't actually mean code testing, although that's also good to talk about. I meant search testing, but yeah.
Search evaluation.
But interestingly, CirrusSearch was sort of on the forefront of regular standard code testing and stuff. No?
I mean, a few years ago, definitely. I think these days, I'm optimistic that other parts of Mediawiki have kind of caught up and are thinking much more about testing. But yeah, CirrusSearch, I don't know. We stood up a long time ago a browser bot, which is essentially a thing that runs on WMF Cloud that stands up an instance of our thing and creates like a Russian wiki and an Italian wiki and an English wiki and a Commons wiki, and then tries to see if it can do all of the interwiki things that our search is supposed to be able to do. We've set up numerous testing environments, automated things. I'd like to think it's forefront. I suppose when you were talking about testing, you meant relevance testing, which would be kind of what my talk at that Haystack conference was about.
Yeah, you gave a talk at the Haystack conference. I'll have a link to it.
So what happens there is that search is incredibly hard to tune or to change. Because somebody gives you a query, they say, hey, I searched for this and the result I wanted isn't at the top. And I can look at it and I can say, if we increase the category weight, then your page would be pushed up to the top. But I fixed that one query. Now there are 10,000 other queries that just got worse because they were fine. And so this is where testing comes in. In search, like going by gut feeling is just not going to get you there. You're just going to continuously make things either worse or not better, or better for some but worse for others. And so you need to find ways to actually evaluate how your search is doing in front of users and see if these changes are actually any better. Yeah. And so we spent some time working out how to do that. And yeah, these days, I don't know. You can.
Well, yeah. There's a page on MediaWiki.org called Testing Search. It lists a few different ways that your group tests possible changes to the search algorithm. There's something called Relevance Forge, something else called the Discernitron. That's an even cooler name. There's dynamic Bayesian networks, and finally A/B testing. And yeah, I think your talk at the Haystack conference was specifically about A/B testing. Are you still using all four of those?
Yes, they serve different use cases. So like Relevance Forge is a pair of servers that we can dump full size indexes into, but index them in new and different ways and see how it happens. This is for things like, so say we were to change the Japanese tokenizer to use the new Japanese specific analysis chain. The way we would test that is we would load it up into RelForge with the new thing, and then we would send a bunch of strings at the new version and at the old version and kind of see what it does. We have a bit of software that will basically source a few thousand queries, random queries from our logging infrastructure, run them, and then report 5% of search queries had a change in results, or 95% of search queries had a change in results.
And if the number is... If the number is high, then chances are something is wrong.
Well, I mean, in some cases, so in that Japanese case, if we change the tokenization, you're basically searching something completely different, and I would expect all the search results to change.
I see. Okay.
If it's, some of them will stay the same, but some of them will be different. But I suppose the critical thing is it'll also give you examples of where they change. It'll give you examples of queries with results changed. Basically various things to kind of tell you what's happening here, and in the case of languages we don't know, information that we can then provide to native speakers that can look at it and kind of tell us, is this getting worse, is this getting better? So RelForge, offline testing, something that happens usually before it's shown to any kind of users or anything like that. So let's see. So we had RelForge.
And then then there's the Discernitron.
So Discernitron is a project that I like it, but it's not something that we're really moving forward with. So traditionally in search, if you were to go to Google or Bing or someone like that, they will have departments of people who are paid to look at search results and look at queries and figure out which search results are the good results for this query. And they will usually grade them on a 4 or a 5 point scale. So, for example, I don't know, if you search for Facebook, facebook.com should be a 5 point rating. Other things
Right.
that mention Facebook should probably be like a much lower rating. But so
Right.
this is how major organizations evaluate their search, or part of how they evaluate their search. They pay a bunch of people to generate these labels, these quality assessments, or not quality assessments, really like what are the best results for a particular thing. And then they evaluate how close they can get their search engine to returning those results. So that's what we did with Discernitron. Discernitron presents you with a search query, a bunch of results that we've sourced from our own search engine, from other search engines, from various things, and it asks you to grade them. We used this initially for evaluating improvements to our search. The problem is you need a lot of data, and it's very tedious to do. Because essentially you need to look at the search query, you need to understand the context of the search query. Like, there was one, it's like, what does the Chancellor of the Exchequer keep in his red box? Well, to figure out what a good result is for this query, first I need to figure out who the Chancellor of the Exchequer is, and to figure out what his red box is. Like, you have to have a lot of context to be able to grade the queries. And so it takes a lot of time to be able to actually evaluate these. But anyways, so that's what Discernitron does. Discernitron is a platform for grading queries, for presenting people searches and search results and grading which ones are the good results. But as I said, it's something that we've moved away from because it was just too tedious. It's too much work. So that's where the dynamic Bayesian networks that you mentioned go in. These are more generally, it's from a family of algorithms called click models. Click models are essentially statistical models that try and pretend that they're the user on a page, and they try and determine things about the user based on. So like your model might say that the person starts at the first result, and then they just scan down the page until they find one they like, and then they click on the one that they like. Right. So we can use that to put it into a mathematical model that basically turns that into numbers. Essentially, we can predict a relevance. Like if we get 20 people that all search for the same thing and we give them slightly different results and we look at what they click, the algorithm can then figure out which results here are good results, which results are bad results. The most obvious thing it will do is that if everybody skips the first result, it says, I know everybody looked at the first result and I know nobody clicked it, so the first result must be horrible. And then that generalizes down to the other results as well. And so that is actually what trains our machine learning models. So essentially, this can generate large amounts of labeled data. So instead of Discernitron, where you're doing one query at a time, this can do millions of queries. It doesn't have to... There's no human doing each step. So you can just do millions of queries. You can do lots of languages you don't even know. There is a minimum amount of data necessary. I think when I evaluated before, we need around 250,000 or 500,000 search click-throughs to be able to generate somewhat meaningful statistics.
Wow.
Yeah.
So you're storing search results for some amount of time after they show up on the page.
Yeah. So
or
there's
search queries
log.
and search results. Yeah.
There's an operational log of every time Mediawiki calls ElasticSearch, whether that's to index a document or to perform a search or anything else. Every one of those requests makes a log message, which basically says, like, how long did it take? What URL did we hit? What were the results that were returned? What was the status of the return? We're able to look back over that. And then, I suppose, relatedly, the way that the clicks are recorded. So when you perform a search, you don't see it anymore, but when you click one of the search results, the UI is going to edit your URL. And it's going to add a token, which is just a random value that was also stored in the search log. So that when you land on the page, it will say that you came from special search and this fancy token. And so essentially we just look through the web request logs afterwards to match up those tokens and say, this was the result list and the person also clicked this one. And I suppose I'll mention, because I know privacy, it's a big thing to us and it's a big thing to other people. These logs do not contain user IDs. They don't really tell us who anybody is. The primary thing we use is sessions. And essentially what happens with a session is if you do not perform any searches for 10 minutes, we throw away the old identifier that we had for you and we generate a new one. So essentially, if you search for yourself now and then you search for yourself in an hour, we won't know that those came from the same person. We try to not keep track of. We want to be privacy conscious, but we also need data to be able to train and make these systems work. So it's finding the right balance there.
And I assume logs get deleted after some point.
So currently logs are deleted at 90 days. Or actually, these might get deleted at 60 days, but 90 days is our privacy policy. That's our guarantee. We are looking into keeping a de-identified and somewhat aggregated form of the search queries for longer. So if you talk to other people in the search industry and you tell them you delete your search queries at 90 days, like, they'll be floored. Like that is not something like Google would never do that. Not even like Etsy. Like Etsy is not a search engine, but they have search. They would never delete their logs at 90 days because there's a mountain of useful information in there.
Yeah, I guess that's true. Sure, right.
Seasonality.
Right.
So like the DBNs that I mentioned, the click models. What makes those work is seeing the same search query multiple times. So if I have 2 years worth of data, I'm much more likely to have multiple copies of the same search than I am if I only have 60 days or I only have 90 days.
Yeah, that's true.
So yeah, nobody else would ever delete those things. I'll bet you Google has 10 plus years. Like they probably just never deleted them. I don't know for anything, but
they just save
I would
everything.
assume.
Yeah. Yeah. Gosh. That's
yeah. So I guess
storage,
I didn't quite finish. But yeah, so we are thinking about how to keep a de-identified version of these for a little longer to be able to. Our current request is 12 months. But that is currently working through with our legal department and with our privacy department and figuring out, is this appropriate? Is this going to be protecting people's privacy enough, et cetera. And also, it's not like this data goes anywhere. It only lives inside of our analytics network, but it's there. And kind of the theory is, well, the old theory, I don't know if we still apply it, but the old theory was that if the government comes and says, hey, you have to give us this information, we would prefer to say, we don't have that information. Sorry, we deleted it.
Right. Yeah.
But on the other hand, as far as I'm aware, I don't think there's any governments that actually get us to give them information. I know there is a thing where Germany made us block a couple pages or something like that.
Oh yeah, the right to be forgotten.
Yeah,
but
otherwise
or
we're not
else
giving away information to governments anyways, or other organizations. The only people we give away information to is researchers that sign research agreements with the foundation.
Oh really? Okay. Yeah, it doesn't sound like you could really extract any useful information from those search logs anyway.
It's an open question. So many years ago, the foundation released a search log, which is just a list of like 10,000, 50,000, I don't know, search queries that were performed. And that had to be pulled back later the same day.
Yeah.
Because it turned out there was private information in there.
Really?
Yeah.
Okay.
So there's kind of some historical knowledge of this happening. And so, I don't know, being extra careful. Same thing happened so there's an old research data set from AOL. And it was supposed to be anonymized, but people were able to go through and figure out like this session identifier, which covers a single person over many days. Like their name is X and they have Y medical condition and they have,
right.
Because if you have enough search logs about an individual person, now maybe not as much on Wikipedia, but if you have your general web search logs, like you can learn a lot about a person that way.
Oh yeah, sure, absolutely. I mean, the amount of stuff Google knows about any of us can potentially know about any of us is staggering.
Yeah.
And Facebook. Well, there's no shortage of privacy issues.
There's lots of companies that know a lot about you.
Yeah.
But we try to not know too much about you. That's our hope, at least.
Yeah. I mean, as long as people aren't searching something like, how do I, John Smith, get rid of this rash or something like that? I don't know.
I mean, people do. I'll bet you there's people that search their name on sites like once a week or something like that, or once a month or whatever, just to see if they're popping up. Right.
What were we talking about? So just a silly question. Yeah, so I assume to search the logs, you also use Elasticsearch, given that that's what it's useful for. Maybe not.
Yeah. So our team used to own the logging infrastructure at WMF just because we were the Elasticsearch people. Thankfully, the SRE department was expanded greatly, and now there are people responsible for the logging platform. So we're still maybe providing advice once in a while, but we don't have to. We don't have to respond to alerts from the logging infrastructure or figure that stuff out anymore, which is nice. It's nice to be able to focus on 5 problems instead of 10.
Yeah. Okay, so we covered Well, so with machine learning, that stuff is interesting. I mean, how much flexibility does the software have to modify the search algorithm or whatever you want to call it? I mean, can it just
so the machine learning completely replaces the final sorting order?
I see. Okay.
So essentially, so in classic search, search is usually described as two phases. There can be more, but the first phase is a retrieval phase where we try and find some large collection of documents that probably match your search. And then the second phase is a more precise scoring where we try and find, the top 10 documents out of this collection of 40,000 documents. So typically Lucene is doing the first part, the choose 40,000 reasonable documents. But now with machine learning, what we've done is we replaced that second step, the scoring step, with a machine learned model where we feed the data in and the model gives you a score and you just sort all of the results by that score.
Yeah, okay.
And I suppose the main win there is that it's very hard to tune search. As I had mentioned before about, you change one part of a query and then 10,000 other queries get worse. So the benefit with machine learning is it's able to actually take those other 10,000 queries into account while it's tuning individual variables, which is something that we had a huge, it was something we could manually do for English Wikipedia, but it was not something that was ever going to be rolled out to, hand tuning the search algorithm was not something that we were ever going to be able to roll out to 20 or 50 languages. There's just not enough people on our team to even think about that. So that's where the machine learning came in. It's a way to automate that process. And you could probably do better if you hand tuned it, but we're 3-4 people. We're not going to hand tune dozens of sites. It's not possible.
Yeah. So for English, for the English language, there's no machine learning involved. It's all
English gets the machine learning as well. We used to hand tune English Wikipedia, but it's better to have everything on the same thing and have just one standard way of doing things.
Right.
Continuing to hand tune English Wikipedia would be possible, so when we first rolled out machine learned ranking, there were various queries that we had never really figured out how to fix that it just kind of fixed.
Okay.
I think one of the ones we always used to use was Kennedy, because Kennedy, there's an exact title match, but people are often looking for JFK. Because the Kennedy family is important, but JFK for some reason is the only one that people are actually searching for.
Sure.
And so we were never able to manually fix that. But when we first, I don't know if it still works today, but when we first rolled it out, it was able to appropriately figure out that JFK is the important one there.
That's amazing. Yeah.
Whereas he used to be result 4 or 5. And we would have ideas for how to fix it. But that's not the only one. That's just an example of a query where it's hard to take. You want to take popularity into account when generating search results, but I don't just want to give you the most popular things. Because, I don't know, when you give people only the most popular things, they don't like the results.
Oh, that's interesting. Okay. So does that use a neural network where you literally don't know what all the logic is behind its decisions?
This uses decision trees. So you could think of it. So essentially there are hundreds of trees, but each tree is an individual thing that just has a condition that it follows the branches of the tree. So the top level might say, is the title match score greater than 20? If it's greater than 20, take the right side of the tree. If it's equal or less, take the left side of the tree. And we just go down the tree, and then at the bottom of the tree, there's a number. So it's very interpretable. You can see exactly what happened. The thing that makes it harder to interpret is there's hundreds of trees. So at the bottom of each tree, it gets a number, but then it sums up a whole bunch of different trees. And that's what gets you your final sorting, your final score that's used for sorting. But it's very understandable. You can plug a bunch of data through it. You can see which nodes, which features that you're looking at are the most important ones, which ones are being used a lot. I suppose randomly interesting towards the top of the tree where it's very narrow, where it's trying to really. So what the tree is doing is it's splitting your data set into more specific pieces. And so at the top where it's very generic, it's looking at title matches, it's looking at category matches, it's looking at things like that. When you get to the very bottom, of the tree, where it's already looking at a very specific subset of the content, that's where popularity starts getting taken into account.
Okay.
So it's interesting that popularity is never used at the general part of the tree. It's only the machine learning never decides to use it there. It only likes using it once it's already got the data split into very little tiny specific sections, and then it applies a popularity boost.
Yeah. So does that mean the popularity will only have a minimal effect on the rankings of pages?
So sort of. The other thing though is popularity is the most used. So if you look at all of the branches of the tree, popularity is the most used one. But that's because it's at the bottom of the tree. So there's 100 nodes at the bottom of the tree and there's one at the top. So it's hard to say which ones are more important. But essentially, so popularity is wildly important, but it's only important within specific contexts. Like just being popular isn't enough for the machine learning to like it. It has to be popular, and it also has to be better. It has to match a bunch of other. I don't know how to describe it.
Criteria.
Sorry, it's a complicated thing that I mostly understand, but it's hard to explain things.
Yeah, this is all vaguely coming back to me from when I studied artificial intelligence. So.
I mean, at a high level, these are decision trees. They are one of the more explainable machine learning models that are out there. ORs, I don't know, you probably haven't talked about it because that's a Wikimedia thing, but ORs is a project that does machine learning for wikis as well, and that one is almost entirely decision tree based as well. Decision trees are very popular. Prior to neural networks do have their benefits, but they're very computationally expensive. And I don't know, at the foundation, I don't know if we have neural networks deployed for anything yet today. I know research is toying with them. They've got some image classification stuff and image grading, but nothing yet today using neural networks in WMF production that I'm aware of.
Yeah, okay. Let me see. Oh, yeah. So that leaves A/B testing.
And this was what my talk was about. So for people that are maybe, if you're at least a little bit familiar with A/B testing, usually you divide people up into two buckets, and then you give one set a green button and you give one set a red button, and then you see how many people clicked the green button and how many people clicked the red button.
Right.
Usually, so there's a statistical measure called variance. It essentially measures like how certain you are that a value is the value that you think it is. In traditional A/B testing, you can just collect a lot of data. You can show your red and green buttons to 10 million people each, and you will get a very specific number, like 50.15% or whatever, something very specific. Yeah. But in search, the problem is nothing is as simple as red button and green button. Instead, you have you have a text box where you can type in anything.
Yes.
Basically, what this means is that you have very large variance. That means when you measure like the percentage of people that click at one, instead of being like an exact number like 75.44%, you're going to have like 75 plus or minus 2%. And because that's so huge, that means you have to make an improvement that is more than 2% better. You have to go from say 70% of people clicking the top result to 73% of people clicking the top result to even be able to measure an improvement. Because otherwise your bounds overlap. So that's where my talk at Haystack was about. It is about a method where you can perform the search twice and interleave the search results together. So every user is in the A bucket and in the B bucket. And that basically removes the variance because your variance was coming from the different search queries. So the users in bucket A have their set of search queries and the users in bucket B have their set of search queries. Because the queries are different, then you get a lot of this variance. So if we put everybody in both buckets, and I didn't invent this. This comes from there's an academic paper from late 2000s. It's a collaboration between a university and Yahoo and some people at Microsoft. I don't know if they were starting Bing yet or not. But anyways, this is all based off of some paper. I basically just read through and figured out how it worked and implemented it and then told some people at the conference about it. And at a high level, that's its goal. Its goal is to remove that variance, to make it so that you can make a 0.5% improvement in something and be able to measure that 0.5% occurred.
Yeah, okay. So what does that mean in practical terms? You search on some query, and then how does that work that you see both
so we
result sets at once?
So I'll perform 2 searches, and we'll give you the top result from search A, and then the top result from search B, and then the top result, and then the second result from search A, and then the second result from search B. And there's there's a couple different ways of doing that interleaving. There's one called team draft. There's one called sequential. There's one called, there's one that is in theory perfect interleaving, but you have to pre-calculate statistics about it's craziness. It's something that only an academic could love.
Yeah.
But so essentially there are different ways to draft the teams to choose that final thing. But the high level idea is we just take a result from A, a result from B, a result from A, a result from B. And
I assume the complication comes because there's a lot of overlap between the two result sets.
And so different ways. Sometimes some ways will skip them. Some ways will define a way to balance the weight that you're giving to each one. There's different approaches, but in the end, they all amount to, just showing one and then the other, and then figuring out a way to assign credit to which ranker gets the credit for having generated this result and putting a click in. And a lot of it, some of it just works by just randomness. So the idea is like whichever one comes first wins. So if A and B both have the top result, then B's result just doesn't make it into the result list, and we just go down to the next one. We just say that the second result was the first result, that kind of thing.
Yeah. Okay. So does that have we covered basically the options for
that's basically how we do testing. I mean, there's other metrics relevance that we collect.
Yeah, right.
Yeah, relevance testing. Yeah. There's other metrics we collect and look at, but they can be hard to figure out. Like I don't know, like we record the 0 result rate, which is the percentage of searches that don't get any results. If that goes up, was that good or bad? It really depends. Like on Japanese, we tested something where the 0 result rate went down significantly. And that was actually very bad because that meant we were returning a bunch of junk results that had nothing to do with the search query.
Right. Yeah, you gotta...
So there's a bunch of other metrics as well, but the interleaving is kind of, in terms of relevance signals, in terms of like how good are the search results themselves, the interleaving is probably our best metric so far.
So are there any big changes that could be coming into the future to the whole? Well, actually, this is a more general question, not just for relevance testing, but in general. I don't know what the state of the art is as far as search, but
state of the art in search is probably not somewhere we're going to end up at. I mean, it would be nice, but I guess I should qualify that. So when I think state of the art in search, I'm thinking Google and Bing with their $10 billion budgets.
Right.
Like that's never going to be where we're at. That's just not. Yeah. But we can do reasonably well. We can apply, the kind of the leading open source solutions at least. Yeah. So there is other fancier stuff out there. Who knows if we'll be able to do it. Our limitations of having to work in lots of languages and doing lots of things, it does tend to limit the amount of time we can spend focusing on really specific things, because we want to make sure that what we're doing is applicable to lots of things of the sites that we work on and not just one or two. Yeah, and a lot of these really fancy things, you basically need to focus on a single language.
Well, are there any changes coming up that whether it's next year or 5 years from now or something to the whole search process?
So a thing that I'm starting to work on right now. So today, autocomplete is always titles.
Right.
What I'm looking at is autocompleting queries.
Okay.
The difference there. So this is particularly about commons, about commons.wikimedia.org. There, searching titles is kind of nonsensical. Like, it's not complete nonsense, but it's not like auto-completing titles on Commons Wiki isn't really what people are doing. They're mostly looking for images on Commons Wiki or other multimedia. And so we would like to provide query completion on Commons instead of title completion. So that's something we've started looking at how that'll work. but it's not that's very early stages. Other things are also, you'll find that they're related around this idea of commons and structured data. So I don't know how much of this stuff is going to be applicable to the wider Mediawiki world. The work on search coming up is definitely more in figuring out how structured data integrates with search.
That's interesting.
For those not familiar, Commons just finished the first stage of a large project called Structured Data on Commons, which is where you can now, essentially, this is Wikidata installed on Commons. It's a federated
sort of.
Wikidata instance. Yeah, sort of. And you can create Wikidata statements. They're not Wikidata statements there, but they refer to Wikidata Q items. They use the Wikidata p-values.
Yeah. Oh, okay. Never mind. I thought you were talking about stuff like putting in CSV files and stuff into Commons.
No, on Commons now you can use, I forget which numbers there, but there's like p something 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 is the property for depicts, and then you can put in the Q item for cat, and you can say this picture depicts a cat.
Okay. Yeah, I didn't
or
know
you
that.
can tag it with. There's ones for licenses. I don't know if they decided to use licensing yet. That's a community question. But other stuff like that, you can now attach structured metadata to multimedia on Commons. And so a question for us is, how do we use that to improve multimedia search? We don't know the answer yet, but that's kind of what's coming up. Also, unrelated to our team, but there are, I know product is thinking about starting to rework the user interfaces for search. So that's things like, again, on Commons, today when you search Commons, you get regular search results with like thumbnails on the side. It would be nice if this was an image grid, like you have when you search on Pinterest or Google Images or wherever else.
Oh, yeah, right.
And so some sort of image grid search results might be coming to Mediawiki as well. But that wouldn't be from our team, because we don't do front-end stuff really. But I know product is thinking about these things. We're kind of advising them a little bit.
Yeah. Yeah, and there's also the whole Wikidata querying thing that's not part of your group either.
That is. We own the Wikidata query service.
Really? Okay.
Yeah. It's two people on my team. It's David Koss and a new team member, Zbyszko Papierski. But they're trying to figure out queries. Essentially, query service. There used to be one guy on it named Stas. He was on it for quite some time, but he moved on recently.
Okay. Yeah. He was on the podcast, interviewed him.
Okay. Yeah. Stas was an awesome
year.
guy. But he's gone on to other things. So we are taking over. Well, he's always been on our team. He just happened to be the primary maintainer. But so yeah, we're working on it. That is a whole separate thing that is difficult and it's hard to scale. We will hopefully figure out what's going on there. I don't know. It's going to be some work to figure out query service.
Yeah. Okay. Are you involved in that in any way?
Only tangentially. Like it's on our team, but essentially David and Zbyszko are primarily focusing on that. Someone's got to watch over these 3,000 requests per second.
There is that, yes. It's not all Wikidata. There's some other sites.
Yeah.
Here's another Mediawiki specific question. There's a few. I mean, obviously, CirrusSearch is the big thing for Mediawiki search in general. There's a few other Mediawiki search extensions. There used to be a bunch of extensions for Lucene specifically, but I think they're all defunct at this point, including the one that was on Wikipedia. And then there was one for Solar, which you mentioned. I think that one's also defunct, called Solar Store. Yep. So I believe the only other search extension under active development is one called Sphinx Search, which uses an open search application called Sphinx. Which is not Lucene based, as far as I know. Do you know anything about that?
I don't know. I mean, I've heard the name Sphinx. I know Sphinx. Sphinx was used for open source document search for decades. It's a quite old project as far as I remember. But I don't know anything about the Sphinx integration for MediaWiki. I know there is another. I can't think of what it's called now. There is another extension that does something with search. It's called Blue something.
Blue Space, maybe?
Yeah, I think Blue Space.
There's Blue Spice. Yeah, Blue Spices is just a general Mediawiki package. I mean, it's Mediawiki plus a ton of extensions. They might have their own search application within the Blue Spice package. It's definitely possible.
Yeah, I know my memory is that they're using Elasticsearch, but they're not using the CirrusSearch extension. That they have their
so they have their own thing. Okay, yeah, that could be. Yeah, but do you ever deal with questions from regular MediaWiki users who are using CirrusSearch and have issues? I mean,
not usually users. So we get administrators, like system administrators, essentially.
Oh, okay.
That will ping us about maybe Elasticsearch isn't.
Oh, that's what I meant by users. Yes, right, sure.
Oh, sorry. So when I think of users, I'm thinking of the people typing the search query.
Yes.
I never hear from them.
Sure.
Well, we do hear from them on the WMF sites once in a while, but not from the third parties. But yeah, so that's the help page that I was talking about earlier. That helps CirrusSearch. That is the primary venue for where I interact with other MediaWiki people that have problems either installing CirrusSearch or getting it to do the thing that they want to do. And sadly, like sometimes the answer is here's how you do it, and sadly sometimes the answer is no, we don't do that. I don't know how to do that.
Okay. What's an example of something that can't be done?
Someone recently, there was a comment, they wanted to add a bunch of content to the search engine and make it searchable on Wiki that wasn't
on Wiki that's an
content.
Interesting one. Yeah, sure.
And so while this is in theory a thing it could do, like that's not it's not a thing that it does do. You would basically need to upload them all as files to MediaWiki and then it would work. And like it's a thing that in theory could be done. Like you could write integrations. Like if that was important, we could. But it's not a thing that we do, and it's not a thing that we will be doing. So just let them know. And I think David, my coworker, pointed him to some other software that does do what they were trying to do. It just doesn't integrate with MediaWiki.
Yeah. Okay. Yeah, it's interesting. Google for a long time had their enterprise search solution, but I don't know what happened with that. They gave up on it. It wasn't making them. It was only making hundreds of millions and not billions of dollars for them or something.
I don't know. I imagine it's something along the lines of it wasn't making enough money to make a difference in anything, and so they canceled it.
Yeah. Okay.
It's got to be a totally different world. Be like, well, we make 100 billion over there. This one's only 10 million. Axe it.
Right. Yeah, but it's interesting that search is one of those fields where the open source tools really dominate the whole market. It seems.
I mean, so there are closed source solutions that people buy. I don't know. So but usually these are what is called platform. I don't know if it'd be a platform as a service. Essentially, these are software as a service companies where, there's one of them is called Algolia. Algolia, you basically pay them and they will index your site and search your site for you. You just point your users at their APIs through your user interface. So there are definitely companies out there that are doing closed source search. But they're usually doing it as a services company, as a software service company.
You never see,
as opposed to being a project that you buy. Definitely anybody building their own search, it's all open source. That's pretty much, there's not a whole lot of other options out there. There used to be more, but they've gone away over time. Yeah.
Well, I guess that's a testament to the quality of Lucene and Elasticsearch and these other tools.
Yeah, I think for most people's problems, they work pretty well. And when you get to the problems of the scale of Google and Bing, you just pay a bunch more people.
Right, buy a few more servers, or a few hundred more servers,
a few more data centers.
Yeah. I think that's most of my questions. If somebody's listening to this and is interested in search stuff, are you guys hiring? Or is the department looking for more people?
So we just hired 2 people. One of them is to replace Stas, and the other one's a junior person that we just added to the team as a new member. So there's no more openings yet unless someone leaves. Of course, so WMF planning process is happening now. So the fiscal year, this is stuff that you probably don't care too much about, but the fiscal year starts in July. So we will basically, when we get new hires, we'll find out in July, essentially or just before July, when the new financial plan comes out for the next year that says who gets new team members. And yeah, so essentially the last fiscal year plan, we've hired those people already, and we will have to wait and see if the plan is for us to have more people or not in the next fiscal. So short answer, no, not yet.
Yeah. Okay. All right. Well, there's no shortage of other companies who need search people, I guess. I think. But,
oh yeah.
Cool. Well, great. Is there anything we missed? We talked about a lot of search stuff, but maybe there's something.
No, I think that covers most of what we do.
Yeah. Cool. All right. Well, it was great talking to you, Eric, and finding out about all this search stuff, which I was really sort of mysterious to me before. Yeah. So, it was good talking to you, and thanks for being on the podcast.
Yeah, certainly. Thanks.
And that was another episode of Between the Brackets. I want to again thank my guest, Erik Bernhardson of the Wikimedia Foundation, for a very interesting interview. I hope you liked it. Thanks for listening, and I'll see you next time.